In this video, we're gonna look at the first law and its ideal gas. So let's write down what's given. The mass is 0.78 kilogram and it's a helium, so that's ideal gas. Initial volume 0.25 meter cube and maintained at pressure P1 equals to 240 kilopascal, and it's maintained, so which saying the pressure 2 is gonna be same as pressure 1, and heat is added until volume doubles, so final volume is twice of 1. Then we need to find the temperature at the end of the process, so that's T2, and the heat required, Q. All right, so since this is a helium, that's gonna be ideal gas, right? And the pressure is constant, so using ideal gas here, we know pressure is constant, so we have V1 over T1 is equal to V2 over T2, right? And then we also know we can get a ratio of V2 over V1. That's going to be equal to T2 over T1. Knowing that the volume doubles, so V2 over V1 is 2, then we can get final temperature is 2 T1. Then in order to find the T2, we just need to find the T1. How do we figure out the T1? We're going to use ideal gas again, because we know PV equal to MRT. And for state 1, P1V1 equal to MRT1. And then we just need to figure out our T1. So T1 is equal to P1V1 over MR. And now let's see what we have. We know the initial pressure, 240 kilopascal, and volume as 0.25 meter cube. The mass is 0.78. And how about R? R is a gas constant for so for helium, the R is 2.0769. So from here we can calculate our temperature, and that's gonna give us in unit of Kelvin. So here I have answer as 37.037 Kelvin. So knowing that, we can go ahead and go back to this, right? Then we can find our T2 is 2T1. It's 2 times 37.037. Then I have 74.075 Kelvin. Okay, so that's the first one. Then they want us to find the heat transfer, and this is a constant pressure process, right? If it's constant pressure process, our first law equation will be heat transfer equal to delta H, and which is M. Delta H, there are many ways to solve. You can use ideal gas, so you can use average CP, or you can use 300 Kelvin. And here we're going to use CP at 300 Kelvin because it's hard to find the average temperature specific heat. So times delta T, T2 minus T1. And the mass is given here. Mass is 0.78 kilogram. And let's go look at the CP at 300 Kelvin. So that's going to be right here, helium. CP is 5.1926. So 5.1976. And then our temperature, T2 minus T1. T2 minus T1, basically it's T1, 37.037. And with that calculation, we have the heat transfer as 150.15 kilojoule. All right, so that's our heat transfer. All right, so that wrap up for this problem. The key is, we know, is first law, and this one is a constant pressure, so we use Q equal to delta H. And in order to solve delta H for ideal gas, you can use several ways, and here we're using CP at 300 Kelvin times delta T. And also we use ideal gas a couple of times for this problem. That's all for this so far. Bye.